Hello, this is Yashvin. In this video, I'll be solving paper 4 variant 1, May-June 2020 0620 chemistry. Starting with question number 1. This question is about elements X, Y, and Z. A. An atom of element X is represented as X with the atomic number 16 and relative atomic mass 34. 1. Name the different types of particles found in the nucleus of this atom of X. So the particles found in the nucleus are protons and neutrons. Two, what is the term for the total number of particles in the nucleus of an atom, which is the nucleon number, that is the sum of number of protons and neutrons. Three, what is the total number of particles in the nucleus of an atom of 34 and 16 of X. So the total number of particles in the nucleus is basically again the mass number or the relative atomic mass, which is represented over here by 34. 4. What is the electronic structure of the ion X with a charge of -2? So as you can see over here, the atomic number is 16, which means that it has 16 electrons in total. But this was a neutral atom, which means the number of protons and electrons is equal. But in this part, however, we have it in the form of an ion which has a charge of -2, which means it gains 2 electrons. And so here the ion has a charge of -2 because of having 2 extra electrons, and that would mean it has 18 electrons instead of 16 as it would have initially started with. So you'd have 2 in the first shell, 8 in the next one, and then the last 8 ones in the third shell. 5. Suggest the formula of the compound formed between aluminium and X. Alright. To write the formula of any compound, we first start with writing the symbols of the elements. So I'll state X over here since I don't know what element this is. So aluminium has the valency of 3 and X over here has the valency of 2. And now we cross them, which gives the formula as Al2X3, and that's it. B1. What term is used to describe atoms of the same element with different number of particles in the nucleus? That is, different number of neutrons. Those are called isotopes. 2. Identify the atom against which the relative masses of all other atoms are compared. This is carbon 12. 3. What is the name of the amount of any substance that contains 6.02 into 10 to the power of 23 particles? So this is the amount or the scale or unit, which is moles. 4. The constant 6.02 into 10 to the power of 23 has a name. What is the name of this constant? This is Avogadro's constant. C. Part of the definition of relative atomic mass is the average mass of naturally occurring atoms of an element. Some relative atomic masses are not whole numbers. Element Y has only 2 different types of atoms. So these are isotopes of element Y because they have different nucleon number. The ratio of atoms present in the element Y is shown. So element Y basically over here has is composed of 2 isotopes of itself, and the ratio of these 2 isotopes is given in the question. Calculate the relative atomic mass of element Y to 1 decimal place. Alright, so otherwise what we would have done to calculate relative atomic mass from isotopic mass is we would multiply the isotopic mass with their percentage composition. But since here we don't have the percentage, we'll instead multiply by the ratio which is given. So we have 69 into 3, which is the ratio, and then we add the other isotopic mass into the its ratio, and then we divide by the total of the ratio, which is 3 plus 5, and so that is going to be 5. Sorry, 3 plus 2, which is 5. And so we have 349 divided by 5, and so we have the relative atomic mass is 69.8. Another point I want to mention over here is that if we had had the percentage over here, we would have divided this by 100, which is why we are instead using a 5 over here, since this is ratio and not percentage. Identify element Y. Alright, so element Y over here has a relative atomic mass of 69.8, and in the periodic table, the closest relative atomic mass is 70, which belongs to the element gallium. The element Z is in period 3 and group 4. 1. Identify element Z. So this element over here is phosphorus. 2. Explain in terms of electron transfer why Z behaves chemically as a non-metal. Alright, so electron transfer basically they want us to mention how whether this element Z is gaining electrons or losing them, and they're saying that it behaves as non-metals. So non-metals, as we know, they gain electrons, and that means we have to mention this over here. But since this question is of 2 marks, we have to write something other than that it gains electrons. So we can just write the number of electrons that it gains. So it gains 3 electrons. 2. Magnesium is a metal. A. Name and describe the bonding in magnesium. Alright, so magnesium, any metal, has metallic bonding. So we'll start by writing the name. And the description of the bonding. So the bonding over here is enforced by the attraction between electrons from sea of electrons. And the positive ions formed when they lose their outer shell electrons. B. Magnesium oxide is formed when magnesium burns in oxygen. 1. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium oxide. The inner shells have been drawn. Give the charges on the ions. Alright. So a magnesium has the atomic number 12. Right. To start with, it has 12 electrons and protons. Similarly, oxygen starts with 8 electrons. But over here, since this is a compound, we have magnesium and oxygen in the form of ions. And as you can see over here, magnesium and oxygen have only one atom in the compound, which means they both have equal charges, because that just means that one of each of these ions can cancel out each other, and that is only possible when the ions have the same charge. Since magnesium is a metal, it loses electrons. It has 2 electrons in its outer shell, and it loses those 2 electrons. So by losing those 2 electrons, it gains a charge of 2 plus. And oxygen, after gaining these 2 electrons, completes its outer shell, which was initially composed of 6 electrons, but since now it gains these 2 electrons, it gains a charge of -2, and hence it also completes its outer shell. So in the outer shell of oxygen, it has 6 of its own electrons, so I'll mark them with these crosses, and then it gains 2 from the magnesium atom. So magnesium ion loses the 2 electrons from its third shell, and now the second shell is its outer shell. And that's it. 2. Write the chemical equation for the reaction that occurs when magnesium burns an oxygen. Right. So we have a magnesium reacting with oxygen, but oxygen exists in the form of diatomic molecules. And so we have magnesium oxide, and since magnesium and oxygen have an equal charge, they both have a single atom in the compound. So the number of magnesium is equal on both sides as well as those of oxygen. C. Magnesium oxide also forms when magnesium nitrate is heated strongly. This is an endothermic reaction. Write the chemical equation for this reaction. So here you're supposed to be memorizing this equation. And so we have magnesium nitrate gives magnesium oxide, nitrogen dioxide, and oxygen. Traditionally, writing the equation this way by starting with complete number of moles is wrong, but since this is one of the equations which you are supposed to be memorizing by heart, I wrote it this way. What type of reaction is this? Alright, so since we are heating this magnesium nitrate to break it down into multiple other products, this is a decomposition reaction because it's being broken down, and we need heat for this. So I'll add in the word thermal, so it becomes thermal decomposition. 3. Name 2 other compounds of magnesium that form a magnesium oxide when heated. Once again, these are supposed to be memorized, which are magnesium hydroxide and magnesium carbonate. Three, sulfur dioxide is used in the manufacture of sulfuric acid. In the first stage of process, sulfur dioxide is obtained from sulfur-containing ores. Name one of these ores. So in our syllabus, we have zinc blende. B. The next stage of the process is a reaction which can reach equilibrium. The equation for this reaction for this stage is shown. 1. Describe two features of an equilibrium. So this equilibrium reaction is always reversible. And the second feature is that the rate of forward reaction is equal to rate of backward reaction. Two, name the catalyst used in this stage. So this stage requires the catalyst vanadium oxide. 3. Why is a catalyst used? So it speeds up the rate of a reaction. Four, explain in terms of particles why a high temperature increases the rate of a reaction, of this reaction, right? Alright, so since this was 3-mark question, I wrote the 3 points in 3 lines. I could have written it in 2 or less lines, but I prefer writing it in 3 lines. 5. In this stage, only a moderate temperature of 450 degrees Celsius is used. What does this suggest about the forward reaction? So despite the fact that a higher temperature can be used to increase the rate of a reaction, and, only a 450 degrees Celsius temperature is used, which is relatively lower. So the only reason that we have for this lower temperature is that if it reduces the yield, and that is only going to be the yield of sulfur trioxide is only going to be reduced if you increase the temperature, in case if the forward reaction is exothermic. So if you increase the temperature, the forward reaction would not be favored. Six, calculate the percentage biomass of sulfur in sulfur trioxide. So we can solve this by writing the atomic mass, relative atomic mass of sulfur, dividing by the molecular mass of sulfur trioxide, then multiplying it by 100. So this is going to be 32 divided by 32 plus 3 atoms of oxygen, and the whole fraction multiplied by 100, which gives the percentage of sulfur as 40. C. Concentrated sulfuric acid is a dehydrating agent which can chemically remove water from substances. Both hydrated copper sulfate crystals and sucrose can be completely dehydrated by concentrated sulfuric acid. Name the solid product formed in each case. So dehydrating copper sulfate crystals forms anhydrous copper sulfate, and sucrose is basically what happens over here is this is an exothermic reaction. Sulfuric acid dehydrates sucrose, and it results in the formation of carbon and water. But since this is an exothermic reaction, the heat given out by the reaction vaporizes the water molecules and leaving behind only carbon. So this is reduced or dehydrated to carbon. D. When propanol is heated with concentrated sulfuric acid as a catalyst, an unsaturated hydrocarbon of relative molecular mass 42 is formed, and one other product. 1. What is meant by the term unsaturated? So unsaturated over here basically means that the compound has at least one carbon to carbon double bond. Write the chemical equation for this reaction. To write the chemical equation, you need to know exactly what are the products and the reactants. So I'll start by writing the formula of propanol. Since propanol has 3 carbon atoms, following the formula of alcohols, we have CnH2n plus 1 and OH, which means C3H7 and OH. I'll calculate the MR of this propanol, which is 3 carbon atoms plus 1 oxygen atoms, and basically 8 hydrogen atoms, which gives me the molecular mass as 60. Right, and then we have the products. We have 2 products as given in the question, one of molecular mass 42 and the other one, and one other product. So if one of these products is 42, what is the mass of the other one? So you simply subtract 42 from 60, which leaves with the mass as 18. So there are 2 products, A and B. The first one has the MR of 42 and the second one is 18. Since this is we're using concentrated sulfuric acid, this means that it's dehydrating this propanol, And that means at least one of these has to be water, since there's removal of water molecules. So one molecule of water, that is H2O, has the MR as 1 oxygen, which is 16, plus 2 hydrogen atoms. So 16 plus 2 is 18, and since these are equal, that means this B is just one molecule of water, right? So one molecule of water has 2 hydrogen atoms and 1 oxygen atoms. And over here, if you look over here, so we're subtracting one of these oxygen atoms. Well, there's only one, so the only one oxygen is getting removed from here, and then we're subtracting 2 hydrogen atoms, and that leaves us with only 6 hydrogen atoms and 3 carbon atoms. So that means the product A over here is C3NH6 plus H2O. So for writing the chemical equation, we start with writing the formula of propanol, which is C3H7OH. Then we have propene, which is C3H6 plus water. Name the unsaturated hydrocarbon formed. So you'll just write the name over here, which is propene. 4. This question is about reactions of bases and acids. A. Ammonia is a gas at room temperature. What is the test for ammonia gas? Describe the positive result of this test. So the test is damp litmus paper, and it turns blue in the presence of ammonia, because ammonia is basic in nature. B. Ammonia reacts with water to form ions. 1. How does this equation show that ammonia behaves as a base? So bases are proton acceptors, and that means they gain a charge of plus. So ammonia over here is gaining a charge of plus over here, which basically is it's acting as a proton acceptor. Two, aqueous ammonia is described as a weak base. Suggest the pH of aqueous ammonia. So the if it is a base, it has a pH higher than 7 and between 7 and 14, but since this is a weaker one, it would be more towards 7 than towards 14. So I'll go with 9 maybe. 3. Describe what is seen when aqueous ammonia is added to aqueous copper sulfate until no further change is seen. So you'll have to memorize this precipitation reaction. So the first observation is that a blue precipitate forms. And then further addition of excess ammonia results in this precipitate dissolving. And then after dissolving, this precipitate results in a solution of blue color. Aqueous sodium hydroxide is a strong alkali that reacts with dilute sulfuric acid exothermically. 1. What type of reaction is this? So an acid and alkali means neutralization. To complete the equation for the reaction between aqueous sodium hydroxide and dilute sulfuric acid. So we have a salt and water, which is sodium sulfate and water, 2 molecules of water basically. D. A student wanted to find the concentration of some dilute sulfuric acid by titration. The student found that 25 cm cube of 0.4 mole per dm cube of sodium hydroxide reacted exactly with 20 cm cube of sulfuric acid. 1. Name a suitable indicator to use in this titration. So according to the syllabus, we can use methyl orange over here. 2. Calculate the concentration of sulfuric acid in mole per dm cube using the following steps. So first step is to calculate the number of moles of sodium hydroxide in 25 centimeter cube of volume. So we have the concentration and volume over here. Moles is concentration multiplied by volume, but we need to have all of the values in same units. Concentration would remain 0.04, and I'd divide 25 centimeter cube with 1000 to convert it into dm cube, which means the answer over here is 0.001 moles of sodium hydroxide. Deduce the number of moles of sulfuric acid that react with 25 centimeters cube of sodium hydroxide. So to deduce the number of moles, we'll use the ratio set in the equation. Since 2 moles of sodium hydroxide react with 1 mole of sulfuric acid, that means basically half the moles of acid react with the total number of alkali. So over here, the half of 0.001 is going to be 0.0005. 0.0005 of sulfuric acid. Calculate the concentration of sulfuric acid in mole per dm cube. So concentration is equal to moles divided by the volume in dm cube. We have the number of moles over here, but I'll first convert the volume, which is 20 centimeter cube, into a dm cube, which is equal to 0.02 dm cube, and so we have 0.005 divided by 0.02, and so the answer, the concentration over here is 0.25 mole per dm cube. 3. Calculate the concentration of 0.04 mole per dm cube sodium hydroxide in gram per dm cube. Basically, all you have to do over here is convert this mole into mass. Since mass is equal to number of moles multiplied by the molecular mass, we have moles multiplied by the molecular mass of sodium, which is 23, plus oxygen has 1 atom. Similarly, hydrogen only has 1 atom. So this is 0.04 multiplied by 40. And so we have the answer as 1.6 gram per dm cube. 5. Ethanol is manufactured by 2 different processes. A for each process, name the organic reactant and state the type of reaction. So the first one can be glucose, which is a form of sugar, simple sugars. And by fermentation, we can obtain ethanol. The other organic reactant is ethene. And by addition of water or hydration, we get ethanol. B. Alcohols can be oxidized to form carboxylic acids. Name a suitable oxidizing agent for this reaction. This one can be acidified potassium manganate. C. Alcohols can be partially oxidized to form aldehydes. Aldehydes are a homologous series of organic compounds. Partial oxidation is achieved by reacting an alcohol with the oxidizing agent in distillation apparatus as shown. 1. Name apparatus A. So A over here is a condenser. 2. On the diagram, use one arrow to show where the water enters the apparatus. Right, so water enters from this inlet over here. 2. The table shows some information about aldehydes. 1. Complete the table. Alright, so we have the molecular formula, and as you can see over here, the number of carbons is increasing chronologically, and so the first one should be methanol. Since this is the single carbon compound, and the last one is the compound with 4 carbon atoms. and as you can see over here, the number of hydrogen is twice as that of the number of carbon. So we have 2 with 1, 4 with 2, 6 with 3, and that should mean 4 twos are 8, but the number of oxygen remains the same in each case to deduce the general formula of aldehydes. So as we said over here, the number of carbon is the number, basically how many carbons are there, so that is Cn, and then the number of hydrogen is twice as that of the number of carbon atoms. However, the oxygen atoms remains the same. E, the structural formula of ethanol is shown. The carbon oxygen double bond group in aldehydes is at the end of the carbon chain. This is a reactive part of the molecule. 1. What is the name given to the reactive part of any organic molecule? So this molecule is known as the functional group. To complete the dot and cross diagram to show the electron arrangement of a molecule of ethanol, the inner shells have been drawn. So as you can see over here, only carbon and oxygen have a double bond. The rest have one bond, which means a single bond, and that means they are all going to be sharing 2 electrons with each other except for the second carbon and oxygen, which share 4 electrons. Right. So this oxygen over here has 2 electrons of its own, and the remaining 2 are going to be of carbon atoms, and then this oxygen should have its own 6 electrons, and so we have the oxygen is now completed. Carbon then shares 1 electron with hydrogen, hence completing the outer shell of this hydrogen atom. Similarly, they all share 1 atom with carbons. And so now, as you can see over here, this carbon atom has 1, 2, 3, 4, 5, and 6. So it needs 2 more. One of them is going to be its own, and the other one is going to be the one which it is sharing with the other one. And the second carbon also has 1, 2, 3, 4, 5, 6, 7, and 8 electrons, which is completed. Propanone belongs to a homologous series called ketones. Ketones have the same carbon-oxygen double bond group as aldehydes, but the carbon-oxygen double bond group is not at the end of the carbon chain. Propanone has the same molecular formula as propanol, C3H6O. What term is used to describe molecules with different structures but with the same molecular formula? So these are known as structural isomers. To suggest the structure of propanone, C3H6O show all of the atoms and all of the bonds. Alright, so I'll start by drawing the backbone chain. As given in the question, the oxygen atom is not present on the end of the carbon chain, which means it can be neither this one or this one. So it has to be the middle one. And then we have the remaining hydrogen atoms. And this completes the valency of all of the atoms in this compound. Alright, so we are done with this paper. Thank you for watching.